morning, everybody. Good morning, everybody. All right. I hope everybody got in okay yesterday and people had a nice time last night. Excellent. Well, it is a privilege, an honor to welcome all of you to Empower 24. We have an incredible opportunity over these 2 days to explore the technologies and the innovation and the impact that this is all having on you, but even more importantly, on the millions of patients that we serve. At Inovalon, we've always had this mission, a mission to improve the outcomes and economics of healthcare. And the transformation we are now witnessing in massive expansion of compute, sophistication of software, arrival and application of AI and machine learning and data is nothing short of transformational for the healthcare marketplace. Is using the word transformational or revolutionary perhaps a little superlative? I don't think so. In our industry, healthcare, change and the technologies that enable it are different than those of convenience in other industries. We don't come to work in the morning to make it so that you can order a book on your phone and have it delivered to your house the next day. Or perhaps select a movie or a song and have it played on demand when you want it. In what we all do, it's about discovering a drug that could save the lives of millions of people that otherwise may never have been discovered. It's about identifying a diagnosis that perhaps would have gone missed in a patient. And most importantly, it's about having the ability to improve quality and the sustainability of the economics surrounding that quality so that entire societies can be managed with better and better healthcare for generations to come. No, our industry is not like other industries. Our industry is mission-driven. In our industry, you, are the stewards of us navigating that change. So I invite you all to sit back as we take a little bit of a journey through time and take a look at just how much change is occurring, and very importantly, how rapidly that is accelerating. So to do this, I'm going to borrow a tool that I borrowed last year. A very closely held secret in the Inovalon technology parcel is our own time-traveling DeLorean. As last year, I had Rajesh pull it up here onto the Capitol last night, and we're going to take a fly back through time. Unlike last year when we were walking through the origin story of Inovalon on our 25th anniversary back to 1984 when I first caught the computer bug, this year we're going to have to go back a little further. Our first stop is actually 1942. We're going to visit a man named John Vincent Adinoff. He's a physicist and a mathematician. And together with his associate Barry, he forms the very first computer, rather unimaginatively named the Adinoff-Barry computer, or the ABC. It had 300 vacuum tubes. 300 vacuum tubes able to do simply addition and subtraction. This first computer had the compute capability of doing 30 transactions per second. From there, we're going to jump all the way to 1955. Why 1955? I'll make it clear in a moment just why. But to take a look at how much compute power had expanded between the origins of the computer to 1955, we have to look at the largest computer at that time, similarly unimaginatively named NORC, the Naval Ordnance Research Calculator, which was located not far from here in Virginia. NORC could do 15,000 computations per second, a significant increase from the predecessor computers of its time. Why? 1955? Well, because of this man. This man is John McCarthy. And John McCarthy was also a mathematician and physicist. He studied at Caltech and then at Stanford. And then he became an associate professor at a school called Dartmouth. And at Dartmouth, he submitted a proposal for something that he thought could change the way computers were used. He said, and I read, "I believe that every aspect of the learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. And an attempt will be made to find out how a machine could use language from abstraction and concepts and solve problems now reserved for humans, and then improve themselves." That is what artificial intelligence is. And this gentleman's proposal was accepted, and he went on to request that the 20 top brains in computer science, in math, and in cognitive sciences were assembled onto the grounds of Dartmouth the following year. And these 20 professors from MIT, from Harvard, from Caltech, from Stanford, from Princeton, from across the country, subsequently became known as the fathers of artificial intelligence. From there, we jump all the way to 1972. As previously, why 1972? I'll tell you in a moment. But the largest computer at the time in 1972 was one called Atlas. It could now do 500,000 computations per second, growing quite significantly 33 times the size of the predecessor capability in the land. And 1972 is quite important because of this man, Dr. Shortlift, who was at Stanford, also a physicist and mathematician, but this one also being a physician, introduced the very first artificial intelligence applied to healthcare. He created a program called MySyn, and MySyn was designed to be able to help physicians identify infectious diseases and recommend the right treatment for those infectious diseases. Now, this early artificial intelligence software was shown to be actually as good as, if not better, than experts at the time. There were experts at the time. Nevertheless, it was never implemented, unfortunately, because of two reasons that still sound familiar today. Because of the concern for liability exposure and the concern for it not being within the workflow of the healthcare system at the time. Nevertheless, this served as a groundbreaking innovation that started the introduction of artificial intelligence within healthcare. From there, we jump to 1993. 1993, a company called Cray Research introduced a change in the way that supercomputers were being built. Instead of what's called vector math, where things are done in a serial process, this started to introduce the concept of parallel processing. And this computer could now do an incredible amount of 300 billion computations per second. That is 600,000 times more compute power than the previous largest computer we were just talking about. So in 1993, a pharmaceutical company, Merck, started to use neural networking and artificial intelligence to examine whether or not they could accelerate drug development. They took a look at data from carbon-13 NMR spectrum of known bioactive molecules. And they said, perhaps we could teach a neural network from these known molecules so that we could search the giant databases that Merck had in organic molecules to decide perhaps which ones should deserve more attention sooner to accelerate the drug development process. Well, the scientist in charge of this was a Dr. Simon Kearsley, and he used the SGI networks at the time and the Cray computers at the time and a certain 24-year-old engineer at the time named me. It was an incredible time to start in the neural networking and artificial intelligence world. And as we started the clock from there, it was just 5 years later that I ultimately decided to start what has become Inovalon. In that year, in 1998, the largest computer in the world had grown significantly. It was called the ASCI Red supercomputer. It was the first computer in the world that could do a 1 teraflop processing of data. A teraflop of data. We're starting to get into numbers that almost don't even make sense. And these are the number of computations. That's 1 trillion computations per second. Per second. Well, we could continue on this timeline looking at many different stops along the way as we explore just how rapidly technology is expanding in the computational capability. But we certainly can't jump past 2022. It was in November of 2022 that I am quite sure everybody remembers the arrival of GPT. Large language models suddenly splashed onto the front page of, well, everything. At the time, the largest computer, single computational structured computer in the world was called Frontier. It was an x86-based processor backed by AMD and its processors, and it was really fast. It could handle 1.1 exaflops. That's 1.1 quadrillion floating point processes per second. That is a 1 with 18 zeros after it. This machine was fast. That was a lot of compute power. But in fact, that's not the compute power that ultimately has led this dramatic expansion of capability that you will all now increasingly see applied to the healthcare marketplace. Because that used an entirely different type of compute. Not based off of x86 processor structure, not even based off of the RISC processors that you all know around the ARM architectures, but in fact, this one used a previously unexpected type of computation that was based around what's called a GPU, our graphics processing unit. Because ironically, a lot that we have to owe today of the massive parallel processing capabilities that we're seeing in AI were actually designed because really intense gamers wanted to have their video displays be amazing. And so the compute that was necessary to deliver the information of a single pixel was in fact important enough to create a processor that could do all of the pixels in giant screens and do them at amazing speed, which brought to bear a capability of processing data in enormous parallel volumes. Obviously, the company that brought this to the forefront like no other company was NVIDIA. And suddenly they were at the forefront of driving compute capabilities at extraordinary speed. So when we start to look at how much compute this actually is, we look at GPT-3 for a moment. GPT-3 used so much compute capability in order to parse out the 175 billion different variables that it considered in its architecture, that it had to be measured in flop days, meaning how many processes per second, per hour, per minute, per day would it take in order to do all this compute. And the number comes out to 3,640 petaflop days. So to translate that into how many calculations were being done per second, the calculation comes out ultimately to 314,496 followed by 18 more zeros. That is, if you remember, the Frontier, the largest computer, single standing computer available in the world, that was 314,496 times faster than that computer. And it arrived on the scene just a couple years later. Well, we barely blinked and GPT-4 had arrived. And GPT-4 parallel processed 25,000 of the most advanced NVIDIA chips at the time, which was the A100 GPU, in order to produce 2.15 times 10 to the 25th processes per second. That is an amazing amount of compute power happening per second. To remind you, that's 21.5 million times more powerful than the Frontier computer, which still at that time was the most powerful single computer in the world. So how does all of this compute power translate into things that we in this room really care about? It's hard to translate the importance of being able to look up some very sophisticated query on the internet that might just be fun versus the applications of these enablements to things that are increasingly relevant to this room. So an examination by Keela et al. In 2023 looked at human capabilities and measured the way AI would approach those abilities on day one of their training process and called that a setting of -100. And then did various performance studies at how a human would perform at those same tasks and assigned that to a value of 0. And then tracked how long it took and whether or not an AI system could in fact exceed the human performance. Well, as you can see in this graph, it didn't take much time. And not only did it not take much time, but it leaves to your imagination how much further those graphs can go over time. Whether reading comprehension, image recognition, language understanding, handwriting recognition, speech recognition, or predictive reasoning, the most advanced of them, in each case, the AI was able to demonstrate the equivalent or better to human performance, and as you can see, in a faster and faster way. Okay, well, none of these listings seem to scream healthcare, when in fact, obviously, they all are involved in healthcare. But what if we look specifically at healthcare? Well, that too has been looked at. And Brin et al. Showed that GPT-4, when asked to take the US MLE exams, the medical licensing exams, how did it do? Well, I spent a good number of years making my way through high school, 4 years in college, 4 years in medical school, and 3 years in residency. And GPT-4 learned all that I learned in seconds. Matter of fact, truth be told, it didn't even study for it. So what's been amazingly shown is actually non-specific AI models actually perform incredibly well in processing data. How well did GPT-4 perform? It scored 100%. 100% on what are called the hard factual questions. What's the right antibiotic? What does this laboratory pattern suggest? What is the diagnosis of this particular set of symptoms? 100%. What about the soft skills? What about things like empathy? What about things like how to navigate the dying patient experience? In those, they were able to show it scored a 90%. It's pretty impressive, considering it didn't even study. So how does that compare to the average? Well, a passing grade, although a closely held secret, is estimated to be around 60%. And the average physician in the United States scores a 78. That's pretty impressive for a machine. So let's recap. From 1942 to 1998, the year that Inovalon was created, the computational power of the most powerful computer available in the world grew by 33 billion times in just that period of time. But far more important than that is the fact that in the subsequent years, from 1998 to 2022, the jump in scale of compute was so significant that you can't even see the predecessor years on the y-axis. It's just a flat line. And then if we say, okay, fine, what's happened since 2022? There again, if we look at the expansion that was brought on by the frontier computer and GPT-3, now all of the previous compute, yet again, can't even be seen on the y-axis. Our scale and scope of compute is growing so quickly that in the blink of an eye, everything previously possible doesn't even amount to anything of volume enough to see on these graphs. And if we roll forward just the extra year it took to go from GPT-3 to GPT-4, we see an almost identical pattern. In fact, you can barely see on the axis GPT-3's computational capability is just a tiny blip at the bottom of this graph. It is moving so fast. And it's no different in software either. Do you remember the world where releases of Microsoft would come out every few years? If you looked at the release of Windows 1 to Windows 3.1, it was 7 years. And the release of Windows 8 to Windows 10 was 3 years. Remember, we as organizations could sit around and debate, how are we going to prepare for it? What's our change management going to be? We had years of advance notice. Well, those days are gone. The advancements in software technology are such that new versions are rolling out constantly. While we're sitting in this room today, there will be new versions of software rolling out. In 2010, when Windows introduced Azure, it rolled out 5 additional software releases that year. By 2023, or actually by this year, it's estimated to be approximately 90 times that number. The number of releases this year will be about 450, and that's as of yesterday. We still got 2 months left in this year. And if you look at the number of patches that are also being released by Microsoft, which is an estimated approximately 890 through yesterday, you have a release cycle that is putting out a new version of software roughly every 5.5 hours. What happened to a new version coming out every 3 years or 7 years? Every 5.5 hours, there's a new version of software coming out, and that's just by one company. And in the same way that compute power is expanding, the same way that software sophistication and the rate of releases are expanding, we also know that the amount of data in the world is just exploding. If we look at the amount of data that was available back in the year that Inovalon was created, it's a pretty impressive 1.5 exabytes. That's a lot of data. A lot of encyclopedias, a lot of pictures, a lot of stuff. 1.5 exabytes of data. Well, you flash forward to today, and it's estimated to be around 147 zettabytes of data. That is, I would argue, an incomprehensible amount of data. No different than the number of processing speeds that are being developed in the computer world. I think it would be tough for any one of us to really understand how much power that is. But this amount of data is 980,000 times increase just since the origins of Inovalon. And what's more is this data is doubling roughly every 2 years at this point. That is unbelievable. Okay, let's take a breath. That's a lot of change. That's a lot of change happening really quickly. What? Why does the CEO and founder of Inovalon have a baby in his hands on the final slide of the introduction speech at Empower 24? Well, this is baby Cooper. Baby Cooper is the son of 2 great people, Joe and Liz Dinkle, Joe is the child of Troy Dinkle, who was the med student assigned to me at Johns Hopkins during my first month of rotations in medical training. Well, as life would have it, we became great friends. And matter of fact, many of the long conversations I had with Troy led to my forming of Inovalon just a couple years after he and I met. He worked for a little while for Inovalon and then went on to do great things in the acute care space. But the reason there's a baby on this slide, well, first of all, because people remember slides with babies on them. But the second and more incredibly important reason is because we are not just any industry. we are not, as I mentioned at the top, we're not trying to ship something faster or travel somebody somewhere more efficiently or identify how to stream something on our phone. Those things are all great. But our responsibility is to make the life of this child incredibly, incredibly special. We, the shepherds of healthcare, have been handed incredible tools and capabilities that have come so quickly during the time that we have been creating our career. The question is, what are we going to do for this child in their life and career? Our responsibility is incredibly important. We here in this room and the great organizations that we represent are the ones that need to discover the drugs that will bring this child an incredible life, to identify the diagnoses, to make it so that equity and availability of healthcare is something that everybody has access to for not just a year or one administration, but for generations. We hold a super important role in taking these tools that have been brought to us by so many people's work and putting it to work to change healthcare. Amidst all of this incredibly advancing and somewhat daunting set of accelerating capabilities, we have a responsibility. Fortunately, we have an opportunity, and that is very simply to make healthcare better. We have at our disposal what no one before us has ever had. There is no one in healthcare. Think about this. There is no one in healthcare that has had better tools at their disposal to achieve the impact that they come to work in the morning to achieve. We have unbelievable compute capabilities, unbelievable rapid progression of software sophistication, and massive, massive amounts of available data to train and inform and bring forward incredible tool sets so that ultimately we can succeed. But to do that, we need to embrace it. We need to be willing to take on innovation at a faster pace, at an uncomfortable pace. We can't do multi-year RFPs or do change management over years. We have to take on a philosophy that the benefit that we are now having in front of us is incredible, and it is our responsibility to put it to work, to change the life and make special and amazing the life of whether it be baby Cooper or the so many other millions of lives that we are responsible for. So as we take on this task, as we take on this responsibility, I can only say thank you. Thank you for being our partners in this process. Thank you for joining us on this journey. And thank you for coming to Empower 24.